Hello. Today we will talk about the financial time series use case in an AI/ML infrastructure. In this demo, we will use the power of AI and deep neural networks to elaborate a model that will try to predict whether the S&P 500 market index will close positive or negative based on historical information from the stock markets. Financial markets are increasingly global. You can use information from an earlier time zone to your advantage in a later time zone. To be able to construct this model and make it available for financial market services, for example, we will realize several steps. First of all, we will obtain data for a number of financial markets from a data store and munge it into a usable format. Then, we will use TensorFlow to build and train models for predicting what will happen in financial markets. Then, we will send trained data to an object store system. Finally, we will serve the trained model using TensorFlow serving into a distributed messaging bus. To be able to achieve our premise, we will need an infrastructure that provides those different services. A bare metal provisioning service, like math, a model-driven deployment and operations, which will be Juju, a data store like Elasticsearch, a distributed messaging bus that will be provided by Kafka, an unstructured data object storage provided by Ceph, and an AI/ML platform provided by Kubeflow. To be able to provide those services, we will need at least one machine for math, one machine for Juju, two machines for Elasticsearch, one for Kafka, one for Zookeeper, two for Kubernetes master, and four for Kubernetes workers. Basically, our architecture can be modeled as follows. What is inside the dashed box represents a Juju environment or a Juju model. The Elasticsearch, K8s, and Kafka services will be deployed on top of virtual machines that are provisioned by mass. Kubeflow and TensorFlow serving services will be deployed on top of Kubernetes. Basically, Elasticsearch will be used to store the raw data that will be used to train our model. K8s will be used to run Kubeflow platform and the TensorFlow serving. Ceph will be used mainly as an object storage system to store our trained model, and Kafka will act as a messaging bus between the model server and the client applications. This is the workflow of our demo use case. Basically, we will start by running a Kubeflow pipeline. First of all, the pipeline will download raw data from Elasticsearch and preprocess it. Then it will train a neural network model with the preprocessed data. Finally, the pipeline will upload the result model into an S3 object store inside Ceph. We will then deploy a TensorFlow server, that will download the trained model from the Ceph S3 bucket and will serve it through Kafka. Finally, we will test a script to predict whether S&P 500 stock market will close positive or negative based on information from other stock markets. As we have seen earlier, the whole demo is deployed on top of a virtual machine. Those virtual machines are managed by mass. So we can see the virtual machine used for this demo, like the Juju virtual machine, Elasticsearch, the master and the worker nodes, and also the Kafka node. This is the whole environment managed by mass. We can also see the environment deployed by Juju. Here is the Kubernetes and Ceph environment. So we can see the Kubernetes workers, charm, Ceph monitors, the OSD, and the Ceph Redis gateway for the S3 object storage. The Kafka environment, where we can see like Kafka messaging bus service, Zookeeper as a backend. The Kubeflow environment, which is deployed on top of Kubernetes. We can see all the Kubeflow component like Jupyter Hub, the pipelines, for example, index for authentication, and the data store environment, which is Elasticsearch. Let's start running our demo now. We begin by accessing the Kubeflow central dashboard, and from where we can access all the Kubeflow components like pipeline, the notebook, and Katib. So we will run our demo with Kubeflow pipelines. So let's create a new pipeline from the financial time series project or pipeline. We create a run here. And for this demo, we will choose which bucket, for example, called my bucket, where we will store our model. The Elasticsearch address, which will be this one. The Ceph-Redis gateway endpoint, which will be this address. The S3 access key. And the S3 secret key. Let's start it. So the pipeline is started right now. It will create a container or a pod for each step of the pipeline. The execution of the pipeline has been finished. We can see all the steps of the pipeline has been run successfully. We can access the log of each step to see what has been run in this step. We can see in the preprocess step that we downloaded the data from Elasticsearch and push it locally. For the training step, we can see that we are doing a training for our model based on the data, and we achieved the accuracy with 72%. And the final step is deploying the result model into the S3 bucket. Now let's check if the S3 bucket contains the model, the result model. We can access it through the S3 command. All right, so we have our trained model in the S3 bucket. Now we will deploy the TensorFlow serving to be able to serve this model. So let's configure it. Excuse me. So we will configure it using the bucket name that the TensorFlow serving will access, the S3 endpoint URL, the Kafka IP from where it will serve the new model, and we will deploy the TF serving charm using this configuration. So let's deploy it. So now we see that a new model called serving has been added to the Juju models, and the charm, the TF serving charm, has been deployed. We can watch the progress of the deployment using Juju command. So the charm is deploying on top of Kubernetes. The TensorFlow serving service has been deployed correctly. We can see here that the TensorFlow serving unit is in active state. We can also check the state of the Kafka model. Now everything here is deployed and works correctly. We can now try to run a test with a financial application. Here we will access our tester machine and run the financial application. So basically, this application will send data about the closing data of those financial markets, and try to and want a prediction whether the S&P 500 will close positive or negative. And we got a response from the TensorFlow serving that the S&P 500 will close positive. Thank you for watching this demo, and see you in another demo. Bye.